So welcome back guys. Now we have a question here like can we change the block size in Hdfs? Answer is simple. Yes, we can. You might be thinking no because the default size is 128 MB. But yes, we can change it, but it comes with its own set of repercussions and consequences. Okay, so the answer is yes, you can change it. And sometimes it can be beneficial and sometimes it can cause some repercussions which are difficult to handle. Let's say the default size was what in HDFS of a block 128 MB. You change it to, I will take an example to explain this to you. Okay. Let's say you have this, let me draw the master slave architecture first. That would make it easier for us to understand. Otherwise, I have to write very much to explain a simple thing to you. Okay. To explain even a single thing to you, I would have to write too much. So to avoid that, what I will do is this is our name node. To clear things first, this is our name node. Let's say this is our client. He passes the file f1.txt to our name node. Okay, our name node keeps a metadata with it. Let's draw metadata to be a little big so that we can show things clearly. Okay, and my name node is monitoring. My name node is monitoring. Let's change this to a different color. Let's say I will change it to yellow. My name node is monitoring 3 data nodes. Okay. Okay, 3 data nodes. Okay, this is the data node 1. Let me just bring it down a little bit down. I will explain everything to you. Just wait a minute. This question needs to be answered because you may face it in your interviews. Okay, let's come here. Let's say this is data node 1. This is data node 2. And this is data node 3. Well, is this much clear? Is this much clear? Next thing. What we can do is, let's say f1 size is how much? 28. Let's keep it the original as it was 270 MB. Okay, 270 MB. So we saw that what was the previous situation, that it will get stored into 270 by 128. That is roughly around 3 when rounded off. So 3 blocks. So f1 would be made into f1 underscore b1 just for representation purpose. It is not represent, it cannot or can be represented by like this. I'm just showing it for just representation purposes. Okay, f1 b2 and f1 b3. Okay, so the metadata, so name node directs the f1 b1 to, let's say, data node 2, f1 b3 to data node 1, and f1 b2 to data node 3. Okay, and the replication factor is, let's say, the replication factor is 2. Okay, so this would be replicated. Let's say f1 b3 got replicated here, f1 b2 got replicated here, and f1 b1 got replicated here. So 2 copies for each of block of our file. 2 copies for each block of our file, है ना? So what happens here? What happens here is, listen carefully. Metadata would be created. How would metadata? I'm just giving a little recap of the previous session. What we covered. Just a little recap of the previous session. So metadata would be like, for file f1, my b1 block is stored in d1 and sorry, yeah, d2 and d3. Sorry, it will be d2 and d3. b2 block is stored in d1 and d3, and the b3 block is stored in d1 and d2. That much is clear. Is that much clear? Now, here comes the crux. Now let's say the situation is I can change this 128 MB default size to, let's say, 50 MB. 50 would make how much? No. Let's make it 70. Okay, 74 is 280. Okay, no, 50. Let's make it 50. Okay, 50 would be fine. 50. Okay, let's make it 50. Or better would be we make it 60, because then it would be too much to handle for us also. 60 MB. I change it from 128 MB default block size to 60 MB. Now the situation here is, if I just copy this thing without actually altering it, I will copy this thing. Okay, and then I will alter it. I am copying. Next what I am doing is, let me just see whatever is happening. See, I copied it. Okay, now this is getting too much in front of my eyes. Okay, now I copied it. My default block size is now 60 MB. शिवम लाइट थोड़ा, ठीक है कोई नहीं, जब हो जाए तो ऑफ कर देना, कोई नहीं. 60 MB is my default block size. Now block size, I am going a little slow so that you can understand each thing that I say. Now my number of blocks would be how much? My default by size of F1 was 278. No, it was 270. 270 by 60 becomes how much? Rounding of 5 blocks, 4 point something, so it gets rounded off to 5 blocks. So now I have to make my metadata even bigger. How? And I have to even make my data nodes even bigger. Like, they were already big, but here in the notepad bigger. In the notepad I have to make it bigger. Okay, so my data node is like this. My data node 2 is also like this. It's just for representation. They were already of the same size. They could have accommodated more data. And now my metadata I'm representing like this. Okay, just see what will happen. 5 blocks means now when I have 5 blocks, I can have F1 B1, F1 B2 block, F1 B3, F1 B4. Are you understanding? F1 B5. These are my blocks. So F1 B1, let's say F1 B3 gets stored here, and F1 B4 gets stored here, F1 B5 gets stored here. Similarly, F1 B2 gets stored here. Name nodes decide. Name node is deciding. I'm not deciding. Name node is deciding that F1 B3 and F1 B4 B5 should get stored here, and F1 B1 gets stored here. Now name node is saying that you should keep the replication factor. Name node is saying that, अरे यार कुछ नहीं आ रहा, ठीक है. So the replication factor now here is true. Replication factor here is true. Let me just close the door. Yeah, now we are better off. Okay, it won't take much time to explain. See, replication factor is again my 2 only. So each of these blocks would get replicated. F1 B3, F1 like F1 B1, F1 B4. Okay, like this, F1 B5, and now each of them have B4, B3 is no, B2 is still not replicated. So F1 B2. Now as you can see, something still would have been replicated. I think now all of them have been replicated two times. If we check 1, 2, just keep patience with me, I will explain everything. 3, 4 and 5. Yeah, all of them. But you will notice earlier we had 6 replications, 6 blocks total with replications. Now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 blocks after replications. After replication, and the metadata becomes like this, that F1 has B1 block which is stored in D1. Yeah, D1, and then it is stored in what is D2, and it is stored in, yeah, D1, D2. Now B2 also we have to keep the data for. Now we have to keep the data for B2 also. Just notice what is happening, and I will explain to you in the last, so that I am taking some time, but just please stay with me. It is for your own benefit only. Okay. B2 is stored where? Again D1, D2. B3 is stored where? Similarly, I enter the data for B3. B3 is stored where? Uh, D1, D3. Okay, data node 1, 3. B4 is stored where? B4 is stored where? D2 and D2 and where? D3. And B5 is stored where? B5 is stored where? D2 and D3. So our metadata has also increased too much. By we have to enter metadata for 2 more blocks. We have to enter, the more blocks we have, the metadata also increases, the replication also increases. Now decreasing the block size led to increase in metadata plus increase in replication. Now for each replication, when there is some task like read or write task will happen, first the operation would be passed from here to client to name node. Name node would access the data of the metadata to assess the mapping of the blocks, and then after knowing the mapping of the blocks, it would go to the specific block in the data node. Let's say I have to do read and write operation in B4 and B4. Okay, so what happens is, and my operations is, let's say I have to do in B4, B1 and B2, read and write operations, some operations. Now what happens is, this what it does is, now to do that, B4 is here and B4 is here, B1 is here and B1 is here, B2 is here and B2 is here. So as the number of blocks increase and the number of replication increases, it requires more processes in your task manager. Let me just show you. I will show the display capture. If I had a replication factor, I will also talk about that. Task manager, these background processes, more background processes it will require to like do the operations, more background processes it will require. So more parallel processing, more and more processes here also it will require. Just wait a minute. Yeah, you're back. More processes would be created to do the operations, more background process also will be created to do the operations. Let's come back to our flow. I will show you some more thing. Let's say if my replication factor in some case was not 2 and 3, then you just think what horrible things could have happened here. B2 we would have to replicate again, where B2 was here, B2 was here, now B2 comes also here. B3 was here, B3 was here, now B3 has to come here also, B3. And B5 was here, B5 was here, now B5 has to come here also. So now in this case, the blocks, the replication increases more as the replication factors increases, as the name node decides the replication factor to be more, the metadata will also be increasing more, like D5, D4, D3, D2, D1 and whatsoever. So what will it will do now? It will be a very heavy load for the name node to handle the metadata, which will become very big. It will become very big, and too many processes, because of the number of replications increasing and the metadata increasing, too many processes and too many processes and too many background processes will run, which will increase parallelism. It will increase the parallelism. That means too many processes will run parallelly, causing heavy load. And this metadata, too much metadata, will become heavy for name node. Like this, too many parallel processes will require CPU, like to memory from the CPU to run them. Like more cores will be required. More cores means, like, to run processes parallelly, you have to divide your CPU into cores. Now you will require 4 5 cores. More cores you will require to run more processes. Okay, and too much metadata will become too heavy and too difficult for name node to handle. So that's why we usually don't decrease the size from 128 MB to lesser. It is very, this size 128 MB is very carefully calculated with research. Now, if you increase the size, let's say from 128 MB to 512 MB, in this case, what will happen is, yes, it will decrease the number of blocks. First of all, you must have understood. I would not explain this with diagram, because obviously it will increase the number, sorry, increase, not increase, it will decrease the number of blocks. As you can calculate, like the size 270 by 512, it will just require one block, it will just require one block. Even 270 by 200, if it was 200 not 512, so it will require two blocks instead of earlier the three blocks that we were using. And then it would cost less metadata, so less processes and less daemon processes running parallelly, so less load for CPU to give more resources to us. So what this will do is, yes, it will uh, reduce the load for the name node and for the CPU to give more resources to the processes. Yes, there will be less parallel processes running. Okay, but the thing is, now you have larger size blocks. You have larger size blocks inside your data node. Inside your data node, F1 B1, let's say for 200, and F1 B2. To perform read or write operation on these blocks now would take more time, because it has to scan through the entire block. It has to scan through the entire block and then perform the operation. So the read and write operations would take time. Any operation would take more time. And if it was 512 MB, like the original only, like it was 512 MB, then, sorry, then this block would have been even bigger. Would have been even bigger. What would have happened? Then this block would have been like even bigger block, F1 B1 F1 B2. Okay, now in this case it would have been bigger and more read and write operation would take more time. Read and write operation would take more time. Now there is one thing I forgot to tell you. Those who have come till the end, they will know it, others won't. There is a, not only the read and write operation would take more time here, because the size of the blocks have like increased. There is one more thing that would happen here. Just see why we were thinking, first of all, to increase the block size or decrease the block size. I just forgot to tell you this in the beginning. We were thinking because F1 size was 270 MB. It was getting stored in 3 blocks, B1, B2 of 128 MB each. Okay, but and B3, like 256 is occupied till here. Okay, now rest of the 14 MB is occupied here, but this space will get wasted. This 128 minus 14, what it is? 114. This 114 MB space was getting wasted. That's why people think that can we change the block size in Hdfs default block size? Yes, you can change if you don't want the wastage to happen. You can change it to a lesser size, 128 to 60, but you will save the wastage. You will make less wastage. As you can see, 270 divided by 60, how much it is? 270 divided by 60 is 64. 240, 60 into 4 is 240, and only 30 MB of data is being wasted than earlier 114 in the fifth block. Okay, in the fifth block only 30 MB of data would be wasted instead of 114. But what happened here is when you try to reduce, your metadata increased very much and your number of processes running parallelly increased very much. That's what happened as a consequence. And in the reverse case, if you try to even increase it from 128 to let's say 200 or 512, there will be even more wastage. There will be even more wastage than you can even imagine. Instead of 114, now let's say you are doing 200, let's say 200. So there will be no B3. First of all, there will be no B3. If my now default block size is 200 instead of 128, there is no B3. Sorry, this video went long a little bit, but I am just trying. Now B2, what happens with B2? Only 70 MB is required as a remainder. So 70 MB is taken in the second block. But now 130 MB is getting wasted. 130 MB is getting wasted instead of 114. So the wastage increased. But in here, what happens? Metadata reduces and the number of processes reduces, but the operations time it becomes more. The read and write operation times will become more. But in the case of where the block size has been reduced, the read and write operation time would be less, but to handle those number of processes would be difficult for name node and for CPU. Their time would be less, but to handle them would be difficult. So in those cases, that's why it is said to preserve the wastage, you can reduce the size, or to make the processes like what you can say, when you want to increase the size to reduce the metadata and to reduce the number of processes, you can increase the size, but at your own cost. That's why 128 MB has been taken as the default size by a very careful research. This was it for the video. If you can increase or decrease the block size or not.